Oh, it worked! Holy cow! First try. Okay, I guess I have to use Firefox in this class. That's really weird. Now you need to focus. Now the only bad thing is you guys, well, I guess you'll be able to see here. All right, so we're just going to keep it here so you guys can tell me if I'm off camera, but I shouldn't be off. Yeah, I shouldn't be off camera. All right, so, oh, I forgot to give you guys a synthetic division thing on your long division. I forgot about that. I'll get you tomorrow. Okay. All right, so did you guys feel pretty good about long division? Okay.
Nope.
Nope. Well, you better be. All right, so here I'm going to teach you the shortcut. Okay, what if I want to take a polynomial 2x cubed minus 7x squared plus 5, and I'll divide by x minus 3. Okay? Now maybe I'll do this problem twice so you can see, especially since Skylar said he forgot how to do long division. Do you want to help me do that, Skylar?
Yep.
Because you want to be awesome at this. All right, let's do it. We're going to do long division just as a quick review. 2x cubed minus 7x squared plus 5. Now, the one thing I am going to mention here, notice we have no x term. If you put a gap here, that might help you. Okay? All right, so does x go into 2x cubed, Skylar?
Yeah.
How many times?
3.
No.
What?
X times what is 2x cubed?
X squared.
2x squared, right?
2x squared.
2x squared. 2x squared times x is?
Wait, 2x squared times is 2x cubed.
2x cubed. 2x squared times negative 3?
Is negative 6x squared.
Negative 6x squared. Now we're going to subtract, so I'm going to change my signs. That's going to go away. Negative 7x squared plus 6x squared is?
Negative 1x squared.
Negative 1x squared. Okay. Does x go into negative x squared?
Yeah.
Yeah, how many times?
Once.
Negative x.
Negative x.
It goes in negative x times. Negative x times x is?
X.
Negative x squared. Negative x times negative 3?
Positive 3x.
Positive 3x, okay? Now I'm going to change my signs, okay? Got a 0 here, right? So the x squareds go away. 0 minus 3x is?
Negative 3x.
Negative 3x. Does x go into negative 3x?
Yep.
How many times?
Once.
Nope.
Negative x.
Negative. So x times what is negative 3x?
Negative 3.
Negative 3. Negative 3 times x is?
Negative 3.
Negative 3x. Negative 3 times negative 3?
9.
Positive 9. I'm going to subtract, so I'm going to change my signs. That's going to go away. 5 minus 9?
Is negative 4.
Negative 4. Does x go into negative 4?
No.
No, so therefore?
It's a remainder.
That's my remainder. So how do I write my remainder?
R negative 4.
No, don't put an R there. I want you to say plus negative 4 over x minus 3.
Okay.
Okay? And that's your answer. Okay? Yes?
On the second step, I'm just wondering, when you do the negative x after 2x squared minus x, it'd make it negative x and then positive 3x, right? And then it changes it?
Okay. So when you're doing regular division, let's do regular division. We're going to divide 3 into 94. Okay? So 3 times what is 9? 3. 3 times 3 is 9. Now what do? you subtract the 9.
Yeah.
Okay? So going back to here, negative x times x is negative x, as x squared, as you said. And negative x times negative 3 is positive 3x, as you said. But just like here, when we subtract the 9, I've got to subtract these. And so the easiest way to subtract them is to just change all the signs, because then it makes it easier.
All right, perfect.
So I did the same thing. Okay? All right, now who wants to learn a shortcut? Okay? We're going to do this exact same problem with a lot less paper and hopefully faster. Okay? Now, it only works. It only works if there is a number 1 here and there's a 1 on the exponent. Okay? It doesn't work if you can change it so that it's x to the first and there's a 1 here. So like if I had 2x minus 3, I could do it, but I would have to factor out the 2. And that, in fact, this would be x minus 3 halves. Does that make sense? So it has to be a 1 here. Has to be a 1 here. If it's x squared minus 3, can't do it. This is what we're going to call synthetic division. Okay? Synthetic division is way cool. Okay? But it only works if I have x to the first power, and it can be plus or minus, I don't care. Yes?
Sorry, is that called the quotient or the dividend? Like a negative divided by?
This is the divisor, this is the
Oh,
dividend. This is the quotient. Yeah.
Okay.
Okay? I'm not going to ask that. I just want you to make sure you know how to do that. Okay? All right, synthetic division. Okay, here's my factor, x minus 3, right? Okay? If it's a minus, I'm going to make it a plus. So whatever, it's the opposite sign of whatever that is. Okay? Now, I'm going to just write the coefficients of this here. Now notice there is a plus 0x to the first. And remember, I put a big gap right here. Okay, you need to pay attention to that when you're doing synthetic division. So the coefficients are 2, negative 7, 0, and 5. Okay? Now, that's going to be the most common mistake is people are going to forget the 0. But you'll never do that. Right? Okay? Because you were listed and plus it's being recorded. Okay? You've all sworn to me, raise your hand, I swear I will never forget the 0.
Oh, I can't do that.
Okay? Okay, so let it be recorded. Everybody in the class raise their hand. No, I'm just kidding. Okay? Don't ever forget that. Okay, so here's what we're going to do. We're going to add down, and then we'll multiply. Okay? 2 plus 0 is 2. Okay? Notice I got a 3 times 2 is 6. Negative 7 plus 6 is 1. 1 times 3 is 3. 0 and 3 is 3. 3 times 3 is 9. Wait, did I forget something wrong? Oh, this is a negative 1. That's why I did it. I messed up. Negative 1 times 3 is negative 3. There we go. Now I'm right. Now I've got my negative 4. Okay? So the cool thing is here, okay? Notice I've got the same thing. Now this becomes 2x squared minus x minus 3 plus, this is your remainder term, plus remainder 4 over x minus 3. So that's the exact same answer I got there, with much less space.
Will be the same.
Okay? And if you can't, oh, it's backwards here though, sorry, I forgot about that.
It will be the same, the remainder instead of put like plus minus 4 over.
You always add the remainder, so plus a negative, yeah.
So you're always going to add it?
Yeah.
Oh, okay.
Yeah, always add it. Does that make sense?
No.
Nope?
Your back was kind of covering,
What was I
what I was
covering?
going, so I was kind of trying to make sense of it.
Okay, should we do another one?
Yeah.
We don't know if it's.
All right, we'll do it up high so that everybody can see, I know.
Felt that we
Wait,
could-
where,
I wish this didn't take up the whole friggin' board, unless, well,
so when you're doing it this way, where, like, how did you come up with the 6?
Well, let's do you want me to do this exact same problem again?
No,
Yeah, do another one.
Let's do another one.
It would help if the original problem is there without all of the math from the previous go through.
Yeah, I just wanted to show you that I got the exact same answer. That was why I did that, though. Okay? So let's do another one. In fact, we'll do one from yesterday, or whenever it was, last time we met.
You're looking for the 6x.
All right, here we go. Where's my eraser? Okay, we'll start this up high, okay? And I'm gonna have you guys help me this time since you saw, so we'll pick on somebody like Josh right up front, because you can see everything, right?
Yeah.
All right, so if I've got here, so I want you to use synthetic division on 6x squared minus 26x plus 12, and we're gonna divide by x minus 4. Okay? So help me to use synthetic division. So I need a little box here, right? What do I put in my little box?
Positive 4.
Oh, I picked on Josh.
Oh, I'm doing it. Oh,
Yeah.
you put the 4 in it?
4. Thanks, Landon.
Sorry.
No, that's cool.
You're welcome.
All right, what do I put here?
Coefficients.
All the coefficients. The coefficients are
6,
6,
negative 26,
negative 26.
and 12.
Okay? Now we're gonna, what are the two steps that we're gonna keep doing over and over? Add
Or
down.
add down and multiply.
And multiply.
So
Okay?
you always take the, from the x minus 4, you take the opposite of that.
The opposite. Okay? All right, so 6 and 0 is
6,
6. 6 times 4,
24,
24. Negative 26 plus 24,
negative 2,
negative 2 times 4,
negative 8,
negative 8. 12 minus 8,
oh, sorry, 4.
4. Okay, so now I'm done. This is my what? What's my remainder? Thank you. Okay, what does this turn into?
X squared minus 2.
No, it's, so I started with an x squared, so it just becomes a plain old x. You just go down 1.
Oh, really?
Yeah.
Oh.
So this becomes 6x minus 2 plus my remainder, which is
4
4 over
x.
x minus 4. Isn't that a lot faster than long division?
All right,
A
now,
lot less paper?
Yeah.
You guys aren't wasting any trees?
now,
Kyle?
I don't care, I'm slow. Where did you get the 24 from?
6 times 4,
Oh, 6 times 4, got it.
24.
And then
Then you add down negative 2
2,
times
negative
4.
2 times 4. Okay,
Right? Okay?
got it.
Patrick?
We were originally dividing by 2x minus 8. We take out the 2, right? For the final answer, would we divide it by 2?
So if you had 2x minus 8, you could rewrite that as 2 times x minus 4, right?
Yeah.
So you'd write it that way.
Oh, okay. We just
Yeah.
give it 2.
Okay? What another way to think of this, if you had a factor that was 2x minus 8, you could say 2x equals 8, divide by 2, x equals 4, and then you could rewrite that as the factor x minus 4. Does that make sense? Okay? All right, so now you're all probably wondering, why do I care about this, right? Who was wondering that? Nobody was wondering? Thank you, Landon. Because most of you are like, why am I in this class in the first place? It's only because I have to graduate, right? Okay. So, it leads to this. This is called the remainder theorem.
Your laughter doesn't make it any better.
The remainder theorem, okay, says that if some polynomial function of x is divided by x minus c, then the remainder is P of C. Now, some of you like that. It's kind of a useless theorem for me. Because all I really want to do is the reason why I'm using synthetic division, I want that to be 0. But if I was just looking for the remainder and I didn't want to do synthetic division, what I could do is I could say, okay, I'm going to find the remainder. I'm just going to find P of 4, okay? Now, according to this theorem, what should the remainder be? It should be 4. Should we prove that?
Sure.
Okay, so Mauricio, can you tell me what P of 4 is?
6, 4 squared
4 squared
minus 26, 4
times 4 plus 12. Okay, 4 squared is 16 times 4, 64.
6.
16 times 4, 16 times 6. 16 times 6 is 96, right? I'm off my game today. I didn't even watch the Super Bowl yesterday. 26 times 4 is minus 104 plus 12. So 96 minus 104 is negative 8 plus 12 equals 4. La! I got the remainder.
So we're just basically proving the remainder.
Some of you guys are going to like that theorem. I think it's kind of useless personally.
So is it basically just to make sure your division was right?
I guess. Yeah, I guess you could do it. That's the only reason I can think you'd want to use it. Okay?
Just for me.
Some of you like to go through and say, well, if I can get a 0 here, there's no remainder. And then you're going to have to repeat this anyway. And I'd rather just do that and save the step, personally. But it's there. Okay? If I ask you a test question on the remainder theorem, you could find out the remainder either by doing synthetic division, or you could just say, oh, I'll just find P of C. Cool.
Just like.
Okay?
Well, now that you put it that way, it is useful, right?
Yeah. So they've also got the factor theorem. I really don't like that I have to erase so often, but I know you guys can't see if I get too low on the board. I wish that didn't take up the whole board. And I don't like to write on the graph. We've also got what's called the factor theorem. Okay, the factor theorem says C is a 0 of P, and I'm going to give you this cool abbreviation. IFF stands for if and only if X minus C is a factor of P of X. Okay? So let's do an example just to prove this theorem. This one's more useful than the last theorem, but they're both kind of related to each other. Okay? Let P of X equal X cubed minus 7X plus 6. Show P of 1 equals 0 and use this fact to factor P of X. Okay? All right, so we could use the remainder theorem, right? So, whose turn is it? It must be Max's turn. Can you show me that P of 1 is 0?
Just plug it in.
Plug it in. What's P of 1?
1 cubed
1 cubed,
minus 7
7 times
1
1
plus
plus 6. So 1 cubed is 1 minus 7
plus 6.
plus 6 equals 1 minus 7 is
Negative 6.
negative 6 plus 6? 0. Okay. That was cool. Now, what that means is I can either do long division or I can do synthetic division. And I'm going to pick on Keegan, and you're going to tell me which one you'd rather do.
If you use long or synthetic?
Long or synthetic?
Synthetic.
Synthetic, okay? So if P of 1 equals 0, what is the factor associated with that?
1, 0.
It's going to be x minus something.
1.
X minus 1, are you sure?
Sure. Yeah.
Sure?
100%.
Sure, you're sure? 100% you're sure. Okay, she's good there. All right. So that becomes the factor, and we're using synthetic division. So if this is the factor, then what? What do I put in my box?
Me?
Mhm.
1,
1, and my coefficients are?
1, negative 7.
1.
What?
You swore to me you weren't going to forget.
Oh, 1,
Get the 0. Okay, it'll mess up your whole problem. Now, we're going to add down 1 and 0 is 1. 1 times 1,
1,
1. 0 and 1,
1,
1 times 1.
1,
Negative 7 plus 1,
negative 6.
negative 6. Negative 6 times 1, negative 6. And I got a finally 0. So I got a remainder of 0. So that's awesome. So what does this become? If we started with an x cubed, this becomes a x squared plus x minus 6. Okay, so now what I've done is I've taken this and I factored it into x minus 1 times x squared plus x minus 6. Can you factor that, Camilla?
Would it be x minus 3x plus 2? Or no, x plus 3x minus 2.
X plus 3, x minus 2, is that what you said?
Yeah.
So plus 3 minus 2 is plus 1, 3 times 2 is 6. Perfect. So we've got x minus 1. So we factored that, and if I were to graph it, I would have zeros at where, Breezy?
Negative 3, 2.
Negative 3, positive 2, and positive 1. Power function is? X to the third, right? So it's going to start high or low?
Low.
Low. I've got a multiplicity of 1, so it's going to cross. We're going to go to positive 1. We're going to have multiplicity of 1 is going to cross, and then we're going to go to 2. It's going to cross again. Do you see why synthetic division is so darn cool now? Okay? Now, rather than use the factor theorem, I would just go straight for the throat, and I would go here. I would get my 0, and then I would go here. Okay? So I would bypass a lot of those steps. But anyway, you should know what is the factor theorem, what is the remainder theorem, and now you know why this is cool. We're going to start factoring like crazy. So quiz tomorrow is the rest of section 3.3. See y'all tomorrow.